Hi, my name is Youngbin Lee. I go also by Ben. This is my MVP submission for AgentForge, which is going to be a clinical copilot for OpenEMR, which is an open source software that allows users, which are medical professionals, to get access about their patients. Um, when we started, we first did an audit of the system that exists, and we found a few key things that is going to inform the rest of our decisions going forward. I'm going to surface three of them here first. Um, First, the API log is a table, and it captures personal health information by design. The encryption is opt-in and off by default, and that presents a certain security vulnerability that we want to be considering going forward. Another thing is that the functionality that captures active medication in patients is actually a merge with conflicts. It's not tied to a single table and often has disagreements. So in this case, we found a certain patient that has a certain medication saying it's active and inactive simultaneously in different tables. So when we construct our own agent, we would want to deal with that conflict as well. Another thing is that there is 0% RX norm coverage in fixtures. What I mean by that is that at least in the demo data that we had, there was no conversion from the text information about medication. It was saying the name of the medication in text and not into the numeric code that is used in a lot of these systems, and that limits the amount of structured reasoning that we can do, like comparing different kinds of dosages and medicines and how they respond to each other and whatnot. And these are things that we want to be addressing going forward, while some of that may not be in the MVP scope. I'm going to be talking about the product a little bit more. The target user is a primary care physician between rooms. I specifically chose this person because I think they have enough data and are in a position to get great benefit from it. So I'm going to be imagining a scenario. At 8:47, this primary care physician goes from room 2 to room 3, and the next patient is waiting. They have 90 seconds to recall who this is, why they're here, and what changed about them, and look at that through charts. Right now, they have to go through 5 different charts and do a manual synthesis in their minds, which is laborious and sometimes maybe jumbled if you have a lot of that paper in front of you or a lot of these charts in front of you. With Copilot, we can have one summary in a very short amount of time with citations, and we're going to be getting into that a little bit more here. So when I designed the architecture, there were 3 large decisions that I made. That this was going to be held as a sidecar shown to the user as a separate service and not embedded into the PHP monolith that is open EMR. And this allows that the failures that exist on this new code base and the system don't cascade into the existing system. There's also OAuth token forwarding. So Sidecar is not going to be holding any system credentials so that it can't access data by itself. It is going to be inheriting access from the user that is logged in and using the system. Another thing that it's going to be doing is, because this is an AI system, we want to limit hallucination as much as possible. That is a concern. And especially because this is a healthcare related product, we would want to be doing that to the best of our ability. And so what we're doing is integrating it into the product specifically by saying that every claim that is made by the Copilot is going to be tied to a certain source ID that exists in the system. So, and if not, it would be rejected by the agent. Current status of the project is that the OpenEMR fork has been forked and then deployed with Railway and MariaDB. The login works, and we are able to hit the FHIR endpoints, and they respond. And the architecture and audit at the moment are complete to the extent that they can be for now. There are certain things deferred to the early submission stage, which is a certain bug that I found with auth tokens and the wiring of the FHIR tools, and then the eval suite. And earlier I talked about the case in which the medicine information is conflicting, and I think that could be a great hero case for our evals, where if the agent is able to handle that gracefully, I think that would be a good sign, not just pick one or the other in an inaccurate way. I'm going to be going over the architecture very briefly. So this is a diagram of the architecture. We would have the chart UI and all that stuff, and have a chat widget on the side. And here I drew a trust boundary, simply saying that all the new code is going to live inside of here and have its own, live separately, and not be a concern for security for the rest of the system or other failures. And inheriting access from the user that's using it. You see how there is an agent loop here, which is going to be the sidecar here. The main thing is a loop where it's going to be getting the prompts from the user and then cycling through the tools and seeing what's they should use. And then from the information retrieved, it's going to verify the source ID. And if it's verified, it's going to surface that information to the user. If not, it's going to reject it. Here you see Langsmith, or some observability tool, is going to be taking hash traces that are coming from the agent. And it's going to be hashing the information one way, meaning that it's going to be redacting the information, hashing the information, and sending it to Langsmith for observability, which is, and there's no way to retrace it back to the original information that was hashed, but that's fine because we don't need to know the name of somebody to know that our system is failing in some way, right? Okay, I'm going to be talking about, I'm going to be demonstrating, actually, the deployed site at the moment. So I'm going to show you the login flow here. This information is stored from earlier. But you'll see how you're able to log in here, and you could imagine how the chat could live here as well. So that demonstrates that it's working. Another thing that I thought was cool is that you can hit this for the metadata, for the SHIR information, just showing us that we're able to access that data as well. But yeah, I'm excited to work on this, and that's my MVP.